Today we shall discuss about piezoelectric actuators. Piezoelectric actuator has many applications, just like piezoelectric transducer. It has both DC and AC application. So actuators can be in both DC and AC mode. AC mode, of course, we have already discussed that all those transmitters are basically kind of piezoelectric actuator. Though in actuator design and transmitter design, there are certain differences. Typically, actuators are used for positioners vibration. That is, that amount, the work done by the actuators are much more than the vibrations. So piezoelectric actuators can be are used as positioners. Motors, and for damping purpose like vibration suppressor. So one of the major application of piezoelectric actuator is in positioners because it can be computer controlled. Positioners can achieve very good precision. And can be controlled precisely. So of the order of, say, fraction of micrometer. Point 0.1 micrometer or so. The application of ultrasonic motors are basically in small device application. can give larger power compared to its size, compared to electromagnetic motors of small size. Say 1 centimeter cube, kind of, or maybe less than that. So when the size becomes small, actually the efficiency of the electromagnetic motors reduces. Now, in case of piezoelectric motor, that is not so, because piezoelectric actuator efficiency does not depend on the size, it depends on the voltage. Efficiency more or less does not depend on size. It depends on the actuation voltage or excitation voltage. So that is a big advantage if we consider smaller size devices. PZT is the leading material in actuator. Because of high piezoelectric coefficient. Because of large piezoelectric coefficient. Though it has hysteresis, so with respect to voltage and displacement, it has some amount of hysteresis, voltage or electric field based actuation. For example, static force. If we apply a static force, of 1 Newton to a piezoelectric device, to a PZT device of say 1 centimeter into 1 centimeter, that is the surface area, and the thickness is 1 millimeter. We would have VZ would be like around 0.3 volt, and Vx would be equal to around 10 volt. So this can be computed. This, of course, DZZ is around 100 or 110, taking around 110, and dx, I think DZZ, sorry, DZZ would be higher. Around 370 PC per Newton, and dxz 110 picocoulomb per Newton. If we take epsilon r, suppose 1200, so dxz would be like Vx is given by dxz fz into x, and epsilon 0 epsilon r by ax, and Vz would be coming from dZz into fz into z. Z is the displacement, x is the displacement, epsilon 0 epsilon r az. So configuration would be something like this. We have Fz. So how much would be the shape change in the z direction? That can be found out by changing z can be found out from the force. Sigma equal to F by A, that is the stress, and delta L, Z would be Fz into Z by E into Az. E is the electric field. So of course sigma can be related by that E into delta L by L. E into L. So changing length per unit voltage would be is a epsilon. For example, say epsilon 3 is D33 into E3. D33 is the piezoelectric coefficient, E is the electric field. So delta L by L would be equal to D33 into E is V3, the applied voltage along the direction 3, and this is L is the length. So if L we have taken as unity, that is 1, then D also if we take 1, delta L would be D33P3. Since these L, two L's cancel out, this L and this L. So which shows that displacement delta L is independent of L. So that is size of the piezoelectric actuator. So this is a very important conclusion. So be it a small or large, we can get the same displacement for the small piezoelectric actuator or a large piezoelectric actuator if we can apply a voltage. Of course, there are breakdown potential, so that of course we should write, though V3 is limited by the voltage gradient, by the limit or breakdown. Potential of the material. So that way the voltage is limited, but theoretically, so it is delta L does not depend on the size of the piezoelectric actuator. So actuators can be in many forms. Piezoelectric actuators can be made in various modes. Of displacement. That is longitudinal, transverse. It can also be made shear mode. Or bimorph. That means two or multiple actuator plates are sandwiched together, having a different orientations of displacement. Or cantilever also. A popular model is also cantilever. A popular actuator is in cantilever mode. So in cantilever mode, so there is a displacement due to the application of voltage. So we can have positive voltage, maybe either same voltage or differential voltage can be given in this top and bottom, while at the middle we can have a negative voltage. So then what will happen? The deformation of the lower plate and the upper plate, which are sandwiched together, two plates are sandwiched here together. So it will act like a bimetal plate that for thermal excitation. So this is a bimorph cantilever. Bimorph cantilever actuators. Then we can have actuators, circular actuators also can be there. So here basically the length will change in this direction. If it is in compressive mode, suppose if it is in compressive mode, then length will change. And due to the Poisson effect, the diameter will increase. So it will have a circular vibration in the radial direction. Here the deformation is in radial direction. Also in length, due to change in length. However, the electrodes are deposited in this direction. So usually therefore the vibration around in the radial direction is taken for actuation purpose. So actuators can be stacked together to have a large effect. However, one of the problem of ejective actuator is hysteresis. Is a polarization hysteresis. So if we apply an electric field, then their charge should be accumulated. Now, if the field is removed, then the charge state should be back to the same positions. So that means neutral positions. However, it is not. It does not happen in practice. Say if we apply electric field, So we are applying high electric field, 50 kilovolt per centimeter. So usually the thickness of the piezoelectric actuator is made small such that it can be operated at low voltages. Then the charge can be surface charge or polarization we can make. Microcoulomb per centimeter square, like 10, 20, 30, 40, something like this. So because of this, the efficiency may suffer a little bit in case of BZT. Force management. In piezoelectric actuator, can be done either in on-off pulse mode or resonant mode or servo mode. So because of the hysteresis, usually servo mode can be done in a small region. Of course, for other kind of material like quartz, hysteresis is smaller in a small operating zone. So pulse mode is often popular. For precise positioning. However, pulse mode usually have less energy. So therefore, softer piezoelectric material has to be used. Low permittivity soft piezoelectric material. Whereas AC drive or that resonant mode is AC drive is used with high Q, high permittivity, hard material. So for example, quartz can be used for resonant mode, whereas for pulse mode PZT can be used. So there are many types of actuators, and usually they need to be constructed in a very precise manner for various applications. Apart from actuators, there is another actuators can be used in back-to-back mode as piezoelectric transformers. So piezoelectric transformer can be fabricated from back-to-back actuators. From actuator connected back-to-back. Back-to-back or or sidewise as well. So it depends on which side of the deformation we want to pick up. If we want to pick up longitudinal sidewise, then that will be two piezoelectric slabs will be connected side by side, or if we want to pick up the displacement feedback from the thickness side, then it will be back to back. So piezoelectric transformer, basically solid state transformer. So let us take a simple one. The electrodes are deposited here on the thickness wise and also sidewise. So if we pick up the XZ component, give an input voltage here, and the output voltage can be picked up. Maybe we can make a same ground. These are just connections. So basically voltage, this displacement, and there is a XZ component also. So that XZ component is picked up for this V out. So in AC mode, this need to be constructed these L1 and L2, need to be chosen corresponding to a multiple of half wavelength. Usually multi-layer construction is used to have a high transformation ratio. So just we have discussed a little bit about